Okay, so now we're going to talk about section 2.5. So section 2.5 is transformations of functions. So we're talking about what a function looks like on the graph. So here are some pictures of graphs of common functions. So first we have a constant function, which is just a horizontal line. So we're talking about the domain. Domain is possible x values, right? And we're talking about the range. The range is possible y values. So for the domain, I'm looking at my x-axis, and I see I can have any x value, right? So that's why it's negative infinity to positive infinity. Cam, would you mind closing that door, please? So another way to say negative infinity to positive infinity is that fancy r, right? Thank you. So either way. And the range is C. So what is C? I'm looking at my possible y values, and I only have one, right? So that's my C. What's the equation for a horizontal line again? Y equals some number C, right? And then we've already talked about even and odd functions. So an even function, so we're bringing a lot together in this section, right? So an even function is, it's mirrored over the y-axis, right? Mirrored over the y-axis. So whatever's on this side is exactly the same as what's on this side. So it's an even function. Okay? Here we have the next one is the identity function. What's the identity function? Does anybody know? So it'd be like y equals x. So that's the equation for a line too, right? It's a line. Again, the domain, my x values are negative infinity to positive infinity. My y values are negative infinity to positive infinity. So it's all real numbers. And this is an odd function. What does an odd function mean again? It's reflected through the origin. So I flip it over the y-axis, and then I flip it over the x-axis. So whatever's over here should be over here. The same, right? So that's an odd function. Then my next common function is the absolute value function. Absolute value is always positive, right? So the absolute value of 1 is positive 1. The absolute value of negative 1 is positive 1. So if ever you have a v that has a sharp corner here, that's the absolute value function. So let me write down what that is. Y equals absolute value of x. So the domain is all real numbers. I'm talking x values, and the range, my y values, are from 0 to infinity. 0 is included, right? Because the absolute value of 0 equals 0. So I can get 0 out of the absolute value function. I can get 0 as a y value. Can you just prop it then and not close it all the way? Hold on. So this is an even function because it's reflected over the y-axis, right? Can put a mirror there. Okay, next is a quadratic function. What does a quadratic function look like? What's the degree of a quadratic function? What's the degree? What's my highest exponent on my variable? Mm-hmm. Good, so this is y equals x squared, right? It can be plus or minus other stuff, but we're talking about basic functions here without anything else going on. So y equals x squared. So the domain, the possible x values are negative infinity to infinity, and the range is hard bracket 0 to infinity. I can get 0 out of this, right? If I plug in x equals 0, I can get y equals 0. Range, we're talking about y values, so I can get y equals 0. Again, even function reflected over the y-axis. Square root function is this. So this is y equals the square root of x. Can I put in a negative into the square root? No, right? Negatives never allowed. So the domain is 0 to infinity. I can do the square root of 0, right? That's why 0 is included, and I get out 0. So that's why we have a hard bracket for both. And this is neither even nor odd. I'm not reflected over the y-axis. I'm not reflected over the x, then over the y. Then we have the cubic function. So cubic is y equals x cubed, right? Degree 3 polynomial. The possible x values are negative infinity to infinity. Possible y values are negative infinity to infinity. This function is odd, right? It's reflected over the y-axis and then over the x-axis. So it's odd, it's symmetric about the origin. Cube root function. Domain is negative infinity to infinity. Range is negative infinity to infinity. And again, it's odd. I can have the cube root of a negative number, right? So that's why we're thinking domain. If I have the cube root of negative 8, what times y equals negative 8? Negative 2, right? Negative 2 times negative 2 is 4, times negative 2 is negative 8. So I can have the cube root of a negative number. Okay. So these are our basic functions from which we will be working. So we're going to talk about how to transform these, how to move these around and do different things with them. But these are your reference functions. So you should know graphically what these look like. Okay, so the first graph shifts we're going to talk about are vertical shifts. Given a function f and a positive number c, y equals f of x plus c is a shift up c units, and y equals f of x minus c is a shift down c units. So if I'm adding or subtracting outside of the main function, then that moves my graph up or down. So outside is up or down. Okay. Horizontal shifts. If I have a graph f and a positive number c, f of x plus c is a shift to the left c units, and f of x minus c is a shift to the right c units. So here I'm adding or subtracting a number inside of my function, inside of my main function. And that shifts it left or right. So inside is left or right, outside of the main function is up or down. Okay? So let's see what that means. So describe the transformations and graph the function. So for number 1, I have f of x equals x squared plus 3. For number 2, I have g of x equals x minus 4 cubed. So which one is inside and which one is outside the main function? So let's see. If I have f of x is x squared plus 3, what's my main function that I'm looking at? X squared, right? My main function is x squared. I'm adding 3 on the outside of x squared, right? So it's on the outside, so that's a vertical shift. I'm adding it, so it's up c units. What do you guys think? Sometimes this is a little bit hard to see for people. So my main function is x squared. Because I'm adding x squared, because I'm adding 3 on the outside of x squared, I'm shifting it up 3 units. So x squared plus 3, this is up 3 units. Okay, so I take my x squared function, which I can look at on the previous page, right? My x squared goes through 0, 0. So if I shift that point up 3, that goes to 0, 3. X squared also goes through the point 1, 1 and negative 1, 1. So if I shift those points up 1 unit, then I get what my function will look like. Okay? So then I have g of x equals x minus 4 cubed. So what's my main function? My main function is x cubed, right? Go back to this chart here. What do you have, right? I don't have the cube root. I have x cubed. I don't have square root. I don't have these ones. I have x cubed, right? This will end up being some sort of x cubed. So my main function is x cubed. I have x minus 4 cubed. So this is on the inside of the cubed function. So let's look at our chart, or our definitions, or whatever we want to call them. So if I add on the inside of the function, I'm going left or right. Because I'm adding on the inside, I need to go left 4 units. Okay. So my x cubed goes through the point 0, 0. I need to move the point 0, 0 to the left 4 units. It also goes through 1, 1, so I need to move that. And it goes through here. So it goes something like this. Right, so if you know a couple points that your basic functions go through, just shift those points and then draw the shape. So does that make sense? So this one I'm adding 3 outside of x squared, right? This one I'm subtracting 4 inside of x cubed. So here's outside. Outside tells me up, down. Inside, the basic function tells me right, left. Okay?
If it's inside, or if it's negative, it doesn't go right.
Let's see. Did I do it wrong? Yeah, it goes right. Thank you. Thank you, Jabari. Okay, so we're good?
Isn't that a cube root function?
Oh my gosh. I'm sorry, guys. Okay, on that note, I think we're done for today. Oh, sorry, guys.